Let's tackle this tricky problem. We've got a function with the natural exponent, and we've got a couple questions, a couple tasks that we want to do. The first is it says find the values of x for which f of x is equal to 0. And so it looks like this thing will be equal to 0 if e of x is equal to 1 or e of x is equal to 4. And this one implies that x is equal to 0. When x is equal to 0, that thing's 0. And this one is a little bit trickier. And we need to take the log of both sides. And when we take the log of both sides, we get x is equal to the log of 4. So that's part 1. Now question part 2 asks us to find the derivative. And if I look for the derivative of this, I'm going to use the product rule. And so I'm going to imagine that I've got two functions here. And so f of x is going to be equal to g prime of x, h of x, plus g of x, h prime of x. And when I take the derivative of this thing, I'm going to have e to the x times 1, just itself, multiplied by e to the x minus 4, plus, well, the derivative of the right-hand side factor is just e of x, multiplied by e of x minus 1. Now, I can factor out e to the exponent x, and then in the bracket, we're going to have e to the x minus 4 plus e to the x minus 1. And we've got e to the exponent x, 2e to the exponent x minus 5. And this is equal to f prime x. Now notice that e to the x can never be negative or 0. It can be a very small number, but it's going to be a positive number nonetheless. And so if we want, if we set f prime of x equal to 0, we have e to the x 2ex minus 5 equals 0. There's no way to get this value to be equal to 0. It's always going to be a positive number, but it is possible to get this factor equal to 0. So why don't we set 2ex minus 5 equal to 0? And when we do that, we end up with ex is equal to 5 over 2. Taking logs of both sides, we get x is equal to log 5 over 2, or log of 2.5. Now we have one critical point. If x is equal to the log of 2.5, which is approximately equal to 0.916, f prime of x is equal to 0, and therefore x is a critical point and a candidate for an extreme value, max or min. Now I have a diagram prepared, but let's look at question 3 first. Question 3 says, in the limit as x approaches negative infinity, what happens to f of x? So let me go down here and rewrite the question. We've got f of x is equal to e x minus 1 ex minus 4. And the limit of f of x as x approaches negative infinity is going to be equal to e, I'll draw it like this. Thinking of a negative infinity, in this case we're going to think of it as some really small number, some really large negative number, some really large negative number, or a really, 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 really small number. And as I said to you before, the natural exponent, in this case, in this setup here, assuming there's nothing in front of the natural exponent, no other modifiers, it can't be negative. It'll just get very close to 0. So if we assume that in the limit we've got e to the negative infinity, if we assume that's equal to 0, then we find that f of x is equal to 4. Negative 1 times negative 4. All right, so those are the answers to the 3 questions. We even added some a bit more. We found the critical point, evaluated the critical point for question 2. Looking at the diagram, you can see that the function is asymptotically approaching f of x is equal to 4 up there. We've got an interior minimum, interior extreme value here, and that was approximately 0.916 or log of 2.5. And given this as being our domain, we can show that this critical point here is the minimum. It's the minimum. It is the interior, or it is a interior extreme point.